Now next, that is center of mass of a thin rod of uniform density. See the theory which we discussed previously, using that we can find the position of the center of mass for the body which one is with regular shape also, right? So here this one is one simple example. Suppose here, as shown in the figure, we consider a thin rod. Which one is with mass capital M and length equal to capital L? Which one is with uniform cross-sectional area and uniform mass density? Now here, that is the linear mass density. It implies that mass per unit length. And here, this particular thin rod, that is placed on the x-axis in such a way that one end of the rod, that is at the origin of the coordinate system. So here, with respect to this origin, where will be the center of mass of this rod, that we will calculate here. Now here the symmetry of the rod, that is with x-axis, so we can easily understand the position of the center of mass, that will be also on the x-axis. Now here we consider infinitesimal small line element having length equal to dx on the rod at a distance x from the origin. Now what will be the mass of this element? So linear mass density, that is mass per unit length, lambda. So that is total mass upon total length. So we can say mass per unit length is lambda. Therefore mass of length dx is how much? So we can write dm, this mass element, that is lambda into dx, where lambda, that is m by L into dx. Clear? Now, as discussed in the previous theory, the position of the center of mass on x-axis, that will be xcm equal to 1 upon m integration x dm. Now here substitute the value of dm, that is m by L into dx. And here we have to consider this type of elements starting from x equal to 0 to x equal to capital L. So here we have to take the limits of the integration 0 to L. So 1 upon m integration 0 to L x dm, that is m by L dx. M will be cancelled. So we can write now, this is equal to 1 upon L integration 0 to L x dx. Integration of x, that is x square by 2. So this is equal to 1 upon L x square by 2, 0 to L, substitute the limit. First upper limit, then minus lower limit. So here 1L will be cancelled. So xcm, that is equal to L by 2. It implies that here we can observe this thing, the center of mass of the thin rod of uniform mass density lies at the center or midpoint of the rod. So here remember this thing, not only for rod. If you find out the position for the center of mass for this type of bodies which are with proper geometrical symmetries, then for all those bodies like circular plate, circular ring, then sphere, then cylinder. So for all these type of objects, the center of mass lies at their geometrical centers. Clear to all of you?